Here we have a right angled triangle. We're told that A is 8.3 centimetres, correct to the nearest millimetre. We're told that B is 6.1 centimetres, correct to the nearest millimetre. We need to calculate the upper bound of C. So first, let's remind ourselves how we would work out C using Pythagoras' theorem. We know that C squared plus B squared would be equal to A squared, the hypotenuse. So therefore C squared would be equal to A squared minus B squared. And so C would be equal to the square root of A squared minus B squared. Now, if I want the upper bound of C, I am going to want to work out the upper bound of A squared, take away the lower bound of B squared. If I want the upper bound, I'm going to be wanting to do the biggest number squared, take away the smallest number squared. So, let's work out our bounds. So focusing on A first of all, we know that's 8.3 centimetres to the nearest millimetre. This is the millimetres here. So the level above that will be 8.4 centimetres. The level below that would be 8.2 centimetres. And so my lower bound is 8.25, my upper bound is 8.35. Now for B, same idea. The lower bound is 6.05, the upper bound is 6.15. So, to working out our upper bound for C then, the square root of the upper bound of A squared minus the lower bound of B squared. Putting that into our calculator, we find that the upper bound for C is 5.75499